welcome to the discussion for section 3.1, which is on quadratic functions and models. There was a couple of questions asked about finding vertex, so we'll work through these problems. Let's start with number one. Number one, we have a function f of x equals negative x squared plus 6x minus 7. And we're asked a couple of things here. The vertex is the very first thing that they asked for. So remember that in a function that looks like this, we would say that it's ax squared plus bx plus c. Okay. This is a quadratic expression, a formula, I don't know, quadratic function, there's a word. So in our case, a is equal to negative 1, b is equal to 6, and then c is equal to negative 7. Right? And the vertex happens at negative b over 2a, and then the function evaluated at negative b over 2a. I realize that probably looks terrible. Let me rewrite this. This is one way of finding our vertex. The x value is simply negative b divided by 2a. And then if you take that value, whenever you get that value for x and plug it into f, that'll give you the y value of the vertex. And that's one way of finding our vertex. Right? So let's go through and do that here. B is 6. So our vertex here happens at the x value. Let's just write this. X value of our vertex is negative 6. Because it's negative b over 2 times a, but a is negative 1 here. And so this is to say negative 6 over negative 2, which is 3. So I have an x value of 3 for my vertex. Right? The y value is taking this 3 and plugging it into the function itself. Right? The y value is f of 3. And so it's negative 3 squared plus 6 times 3 minus 7. I don't have a lot of space here before I run out, so I'm just going to say that this is negative 9 plus 18, which is 9, and then minus 7 is 2. So the vertex happens at x is 3, y is 2. That is to say my vertex is at 3, 2. The other questions that it asks are, does it open up or down? And the up or down depends on the sign of a. If a is negative, this is opening down, and so this is opening down. If it were positive, it would open up. But here, negative, down. And therefore, the next question is this a maximum or a minimum? Let me erase a little bit of this. I have this point, it's at 3, 2. It's not particularly consequential to the graph here, but that's my vertex, and if this thing opens down, then clearly that is a maximum. It's the highest that this thing will get. And therefore, whenever you open down, your vertex is a max. Whenever you open up, your vertex would be a minimum. Okay. Good. Let's look at number 2. Two is essentially the same question, so let's just take a look at it and we'll do the vertex and I'll let you do the rest of it. But we have f of x equals 3x squared minus 6x minus 4. And again, we're looking for that vertex, so my negative b over 2a is my x value of the vertex. So that's negative negative, which is a positive 6, over 2 times a, which is 3, and therefore this is 6 over 6, or 1. And then f of 1, plug that 1 back in here, and I've got 3 times 1 squared, minus 6 times 1, minus 4. 1 squared is still 1, and I multiply that by 3, and it's still 3. 6 times 1 is 6, so minus 6, minus 4. That gives me negative 7. So my vertex is then at 1, negative 7. And I'll let you do the other two. They're just like we did in the other one, except now it's a positive, so it's all the opposite. Okay. 5 is the same question, so let's just look at 5. But we have x squared plus 8x plus 9. And in fact on 5 I'm going to do this a different way because why not, right? There is another way of doing this. If I can turn my function into x minus h squared plus k. Right? If I can complete the square and turn it into this expression here, can you see that on the board? Yeah. Then my vertex happens here at h, k. Right? And we're going to be completing the square in this class and in Math 127. You'll see completing the square pop up. So let's do it now. If I can turn it into this, then I can just grab the values h and k, make sure that you note that this is a minus in front of your h, and so it'll be whatever the opposite of that is here, and then k is just k. But to complete the square, I'm going to look at the middle term here, 8, I'm going to divide it by 2 and square it. Whatever that number is, you just half it and square it. So 8 divided by 2 is 4, squared is 16, right? Now 16 is what I want sitting here, and I've got this 9, so what I'm going to do is I'm going to both add 16 and subtract 16, since I only have one side of this equation to work with. And as long as I add 0, then I'm okay, I don't change anything. But I'm going to regroup this a little bit. I want this 16 to be part of this trinomial, so I'm going to take this 9 and this negative 16 and combine them and just move it off to the side. So that is to say I have x squared plus 8x plus 16, right? This guy, and this guy. And then this 9 and negative 16 I'm going to combine just kind of over here to the side. And so you see I've still got the same thing. I still have x squared plus 8x plus 16 minus 7, that's still 9, right? I've just rewritten it because this trinomial right here is a perfect square. I've completed my square, right? This trinomial is x plus 4 squared. And then I just have this minus 7 hanging out there. H is negative 4, k is negative 7. And that's my vertex. Okay. So it's another way of doing it. You should try it at least once or twice. Do it the other way first, get your answer, and then try this and see if you can get the same answer. Because this stuff will not go away. It's coming back. Alright, that was number 5. And then I was asked to do number 6. I feel like it's probably going to be, yeah, it's the exact same question, so I feel like at this point you can probably do it the first method by yourself. Let's take a look at the second method because there is one little thing that you've got to be careful with. This is negative x squared plus 10x minus 22. Okay. And so when you try to complete the square, if there's anything besides a positive 1 in front of your x squared, you have to be careful. Right? So what I really want to do is factor that negative out, and I'm going to factor it out of everything. Right? Really, kind of, in fact, I'm just going to factor it out of these first two terms, because this 22, I just kind of want it to go away until I figure out what number I want in its place. So if I factor a negative out, I've got this x squared now is just a positive inside here. This positive 10x has to become a negative 10x inside here. And I'm going to leave myself some space because I'm going to add something here, but I've still got this minus 22 that I didn't factor the negative out, so it's not part of my parenthesis. Right? I can choose whichever one of these guys I want to factor junk out as long as I leave that stuff out. Not as a factor, but as plus or minus, whatever's there. Right? Oh, if I go through the same process on the inside of this parenthesis, I'll take that negative 10 and divide it by 2 and then square it. But that's negative 5 that gets squared, and so that's 25. So what I really want is a 25 hanging out in here inside these parentheses, right? And I can do that. I'm going to erase this red so that I can work a little bit here because I've got some manipulation to do. I'm going to add my 25. Okay? And just like the last one, if I add something to this side of the equation, I have to also subtract it. But I have to be careful because I added 25 inside these parentheses that has a minus on it. So really I've subtracted 25 from the right-hand side. And so to counter that on the outside, I have to add 25. Right? It looks weird, but I'm adding 25 on the outside, and I'm really subtracting 25 by putting that 25 on the inside of this parentheses. And that's my 0. Minus 25, positive 25. I'm adding 0 to this equation. Okay? So be careful whenever you have to complete the square inside of parentheses where something's acting on it. Okay. This inside here is now a complete square, right? This is minus in front, and then I've got x minus 5 squared. And then negative 22 plus 25, right? That gives me plus 3. My vertex happens at positive 5, 3. And there I have it. And again, on this one, whenever there's anything in front of that, you may not want to go through this process because you do have to be careful, but definitely try it the other way. And we can try it the other way and make sure that, you know, we didn't goof up. If we go negative b over 10a, that's negative b over 2a is negative 10 over 2 times negative 1. But that's negative 10 over negative 2, and that's 5. Well, that's good because that should match the x value here. And if I take 5 and plug it into this equation, I get negative 5 squared, which is negative 25. Plus 5 times 10 is plus 50. So I'm sitting on a 25 right here, minus 22 is 3. That's good because it needs to match that one. Hopefully that was helpful. If you don't like the complete the squares method, don't do it, but know it's coming back at you sooner or later. So you may as well practice it now. All right, thanks, and I'll see you for the next one.